Welcome back to my recorded classes. This recorded class, we are discussing the topic 5.1 probability theory and especially the second exercise 5.1.2 probability theory starting ideas. Okay, so already we are discussed in one class the probability theory first part, how to find the sample space, and when we are telling two events are mutually exclusive event and exhaustive event, that idea we are discussed already exercise 5.1.1 section. As a continuation of that recorded class, here we are discussing probability theory, the basic ideas. In the exercise 5.1.2 we are doing the questions related to that one. So welcome to this recorded class. Please subscribe my channel for getting more recorded classes. So let's start the ideas. So first I will tell you the questions. What are the important idea we are discussed this section already. Just in brief we are telling the ideas whatever we are discussed here. Okay. So probability of an event, starting with the definition, probability of an event. What is the meaning of probability of an event? So classical definition of probability. Let n of e means number of elements of the event E, be the number of outcomes favorable to the event E, and n of S means the total number of outcomes in the sample space S. Then the probability of an event E is denoted by probability of E. We can use this notation for representing probability. Probability P means probability of event E. Okay, and is defined as probability of E equals number of elements of E divided by number of elements of S. That means number of outcomes favorable to the event E divided by number of the total number of outcomes in S. A simple example we can see this definition. Okay, so probability means number of outcomes favorable to one event divided by total number of outcomes in the sample space S. So number of E divided by number of S, we can say that one. Okay, now for example, a card is drawn from a well shuffled pack of 52 cards. Last recorded class exercise 5.1.1 we are discussed this idea, this card games. So a card is drawn from a well shuffled pack of 52 cards. Find the probability of the following events. Some events are defined here. What are the event? Capital A means the card drawn is a king card. Okay, the card is taken is a king card. B means the card is a red card, and C means the card is a spade card. Correct? Already we are discussed this card. Okay, games. You know the idea. There are 52 cards. 13 club cards will be there. Correct? Totally we have 13 clubs and 13 spade card will be there, and we have heart card 13 and diamond card also we have 13 cards are there. Correct? Now out of this 52 card, as we discussed last recorded class, there are 26 black cards are there. 13 plus 13, first two are the black cards. 13 plus 13, 26 cards are there. Another two 13 plus 13, correct? The heart card and diamond card are red card. We are getting 26. So 26 plus 26, totally we have 52 cards are there. Correct? Now out of that ace card means the A letter will be there. There are 4 ace card will be there. Out of that 2 black and 2 red, totally 4 cards. Correct? And number 2, totally 4 cards will be there. Number 3 also 4 card, like number 4, number 5, number 6, 7, 8, 9, 10, all are 4 cards. Jack card are 4, number of queen cards 4, and number of king cards are 4. Totally 52 cards will be there. Correct? Now here we can define the probability. See some example we can see, we can discuss about the probability. Probability of an event A first. A means the card drawn is a king card. Okay, A means the card drawn is a king card. So what is the probability? First of all, there are 52 cards, correct? So how many numbers are there? How many cards are there in the sample space, or how many outcomes are there in the sample space? Number of S means number of elements of the sample space equal to 52, because we have 52 cards are there, correct? One card only we are choosing, so there are 52 outcomes we are getting, okay, totally. Now the first event A means card drawn is a king card, correct? It should be a king card. So how many king card we have here? Totally we have 4 king card, correct? You can see here, these are the king cards. So totally we have 4 king cards are there. So number of elements of A, because A means a king card taken is a king card, correct? So number of elements of A means how many elements, how many king cards are there? There are 4 king cards, correct? So how can we write the probability? So probability of A equals number of elements of A divided by number of elements of S, correct? Number of outcomes favorable to the event A divided by total number of outcomes in the sample space. So number of elements of A means there are 4 king cards divided by what is the total number of outcomes in the sample space? There are 52 cards. So 4 divided by 52, we will get 1 over 13, correct? So this is the first example. Now if we are going to second example, we are defining an event B. B means the card is a red card, correct? The card is a red card, that is the B event, correct? B means the card drawn is a red card. How many red cards are there? Number of outcomes in B. How many elements in B actually? How many red cards? 26 red cards we have, correct? Number of B means it is 26, because 26 red cards are there. 26 red and 26 black, correct? So what is the probability of B? Probability of B equals number of elements of B divided by number of elements of S, correct? So there are number of elements of B means there are 26 red cards are there, divided by total number of elements in the sample space means 52 outcomes are there. So what answer we are getting? Equal to 1 over 2, correct? Now what is the third part of the question? You can see the card is a spade card. The card is a spade card, that is the third one. Spade card means how many spade cards we have? You can see the spade card, 13 cards totally, correct? Spade means this symbol. This symbol, how many cards are there? There are 13 cards, correct? Totally. So we can say here C means we have spade card, correct? So how many elements in the event C? Number of outcomes favorable to the event C means there are 13 outcomes are there. So what is the probability of C? Probability of C equal number of elements of C divided by number of elements of S, correct? So how many spade card? 13. How many totally outcomes in the sample space? 52. So 13 divided by 52 equal to 1 over 4 we are getting. Hope you understood this example, correct? This is a simple example for understanding what is the meaning of probability. So probability means probability of any event, correct? Probability of any event E or A, B, C, any capital letters you can use for representing event. So probability of an event means number of outcomes favorable to the event E divided by the total number of outcomes in the sample space S. So this is the simple definition of the probability theory or probability. Okay, now we will come to some rules. Axioms of probability. Axioms are some conditions, some rules are there, axioms are there of the probability. What are the axioms? You can see for any event, if you are defining any event, probability value, minimum value should be 0, maximum value should be 1, okay? Probability of A less than or equal to 0, less than or equal to 1, 0 less than or equal to probability of A less than or equal to 1. That means probability, minimum value of the probability is 0, maximum value how much we are getting? 1 we are getting. The probability value should be in between 0 and 1 always, okay? 0 or 0.1, 0.2, 0.3, 0.5, 0.75, 1, like that. Maximum 1, minimum 0. That means the probability of an event cannot be negative. Negative not possible because more than 0, correct? and cannot exceed unity. More than one also not possible. Unity means one, cannot exceed unity, cannot exceed or more than one also not possible. It lies in between the number 0 and 1, correct? Now the second condition, probability of an impossible event. Impossible event means phi, null set, correct? The null event. So probability of a null event is 0. So we can write probability of phi equal to 0. Probability of a null event always become equal to 0. Now the next one, probability of a sure event. Sure event means the sample space, okay? Sure event means S, sample space. So probability of S should be equal to 1. Okay, hope you understood that one. Probability of null event 0, probability of a sure event should be equal to 1. So I hope you understood. Starting probability value 0, that means probability of a null event should be 0, and probability of a sample space maximum value, that is equal to 1 here. Okay, hope you understood that one. Now another one, if A and B are mutually exclusive event. Okay, all of you remember mutually exclusive, what is the meaning? We are studied in 5.1.1 section, correct? So if two events, for example A and B, probability of A union B, correct? How we are writing the rule? Probability of A union B means probability of A plus probability of B minus probability of A intersection B. Okay, this is actually the rule for finding probability of A union B. Probability of A plus probability of B minus probability of A intersection B. Now two events are mutually exclusive, correct? Last recorded class we are studied mutually exclusive means, what is the meaning? A intersection B should be equal to empty, correct? A intersection B should be equal to empty set, correct? So that time what happened? This value probability of A intersection B, it become probability of A intersection B means phi. What is probability of phi? Is 0, correct? That means what happened? This term become equal to 0 if it is two events are mutually exclusive events, correct? So that time this rule, how can we write this rule? That time we can write the rule as probability of A union B equals probability of A plus probability of B, correct? That is what here the third axiom. A and B are mutually exclusive event or disjoint set. Disjoint set means there is no intersection, intersection is empty. So that case this rule become probability of A union B equals probability of A plus probability of B, we can write. So these are the three axioms of the probability or three rules. So 1 and 2 very careful. Minimum probability value 0, maximum 1. Probability of a null event is 0 or probability of a sure event equal to 1 here. Now from these axioms, okay, based on these axioms we can have some remark here or some of the rule we can write like this. For example, we have a sample space S equal to A1, A2, A3 up to AN. Sample space, these are the members. Now if you are taking any outcome, see the sample space A1 is one outcome, A2 is one outcome, A3, A4, AN is the last outcome. Now probability of any outcome, okay, probability value of any outcome should be minimum value 0 or maximum value equal to 1, in between 0 and 1. As I told you just before, same idea only. Probability of any outcome value should be in between 0 and 1. That is the first idea, first remark. Now if you are adding the probabilities of each outcomes, probability of A1, probability of A2, probability of A3 and probability of AN, okay, sample space each elements outcomes probability, if you are adding, what answer you are getting? Equal to 1 we are getting, maximum equal to 1 we are getting, okay? So sum of the probabilities always equal to 1. Sum of the probability, simple event, correct, or outcome, probability of the outcome, single outcome or probability of a simple event, sum should be equal to 1 here. Now if you are taking any event A, for any event A, probability of that event means sum of the probabilities of the outcomes, sum of the probabilities of the outcomes for all ai belongs to that event. So a particular event if you are taking, how we are calculating the probability of that one? Probability of each outcomes in that event. Okay, so these are the some remark we can say that one. Okay, now one picture you can see here. Impossible probability value starting from 0 ending at 1, correct? In between 0 and 1. 0 means what is the meaning? Impossible event. Impossible, it will not happen, correct? So that type of event probability will be 0. Now unlikely event. Unlikely means very rare chance happening. Very rare chance happening. So that 25% happening, like that we can say, correct? So we can unlikely. So probability value should be less. Even chance occurring means 50-50 chance, like that. Okay, so 50% or 0.50, like that, 50%. Okay, likely event means mostly it will happen, that is the meaning likely event, 75%, correct, or 0.75. And certainly sure event means what is the probability? 1 we are getting. So impossible event probability is 0. Likely event means in between 0 and 0.5, like 0.25, like that. Even event means take 50-50 happening. If you are tossing a coin, head getting and tail getting 50-50 chances, correct? Like that event. Okay, so 50 chances or 0.5 probability. Likely event means mostly it will happen, 75%. Certainly means 100%. That means 100% means probability is 1. So this is just a pictorial representation of the probability, just for your understanding. Now we are studied about independent event in the 5.1.1 section. Independent event, correct? Independent, there is no relation, we told. Okay, one event occurring, it is not related to other, correct? Independent events. Now if a and b are independent events, okay, we can write this one, probability of a intersection b should be equal to probability of a multiply probability of b. Just to note this idea, if a and b are independent events, if it is independent events, probability of a intersection b same as probability of a multiply probability of b. Okay, so together happening, that is equal to probability of a multiply probability of b, separate happening. Okay, so independent, that events are independent, that is the meaning of that one. Probability of a intersection b equals probability of a multiply probability of b. Okay, now we will go some rules again here. Theorems on probability. First we are telling addition rule for the probability. Addition rule. Okay, addition rule means, see, you can see already we are studied this idea. Probability of a union b equals probability of a plus probability of b minus probability of a intersection b, correct? For example, you can see the picture here, this picture, correct? We have two events, one is a and the second one is b event, correct? You can see the shaded portion, this is the a intersection b portion, correct? So probability of a union b means probability of a plus probability of b minus probability of a intersection b. Okay, this is not mutually exclusive, that means we have intersection, correct? Now if two events are mutually exclusive like this, that means there is no intersection here, the first picture. If there is no intersection means what happened? What I told you just before, this portion will be 0, correct? This portion will be 0 if it is mutually exclusive, correct? Mutually exclusive set or disjoint set means mutually exclusive or disjoint. Okay, disjoint set means a intersection b should be empty. So probability of a intersection b means becomes 0, correct? A intersection b is an empty set if it is mutually exclusive or disjoint set. So that time this term becomes 0. So that case what the rule we are writing? Probability of a union b equals probability of a plus probability of b, correct? You can see this picture, there is no intersection portion here, correct? There is no intersection, disjoint set, but here intersection is there, correct? So this time intersection is there means this term extra will come, probability of a intersection b will come. So probability of a union b equals probability of a plus probability of b minus probability of a intersection b. If it is going to 3 set, probability of A union B union C means probability of A plus probability of B plus probability of C minus probability of A intersection B, B intersection C, A intersection C, and plus probability of A intersection B intersection and C, correct? So this is the idea here, the first rule here. Okay, now when we are coming to the next one, for any event A in a sample space S, probability of A complement, you can see the yellow color portion, this yellow color portion is A portion, okay, the event A, this is the yellow color portion. A complement means this blue color portion, that means not in A, okay, other than A, that is A complement. Now if you want to calculate probability of A complement, what we are doing actually, see this rectangular portion means it is sample space, full sample space. Full sample space, what is the probability? Probability of the sample space equal to 1, correct? So from the 1, total probability, just to subtract this probability of A portion, so that you will get probability of A complement portion, correct? So what is the rule actually? Probability of A complement equals 1 minus probability of A. So we need to know that rule, we need to memorize that rule. Now same way you can see another two rules, fourth and fifth. S contain two events A and B, then probability of A intersection B complement, probability of A intersection B complement, okay. A intersection B complement means it is same as A minus B. That means what you do, from A delete the B portion, that means you can see this picture, this portion, okay, that is A intersection B complement. How we are calculating that one? Probability of A minus probability of A intersection B. That means from total A, subtract this intersection portion, okay, that is the meaning, probability of A minus probability of A intersection B. Same as you can see, probability of A complement intersection B, A complement intersection B. A complement intersection B means, see, you can see the picture here, this shaded picture, okay, this portion, probability of A complement. A complement means not in A, it should not be in A, intersection B, okay, should be in B, like this portion. This portion, probability of A complement intersection B, or B minus A we can say. From B delete A portion, from B delete the A portion, that is B minus A, or A complement intersection B, means probability of B minus probability of A intersection B. So you can memorize these three rules. Using that picture is better. So okay, it is easy to way to understood like this. Okay, now next point we are going to discuss joint probability. What is the meaning of joint probability, correct? So joint probability means the probability that two events will both occur together. That is the meaning of joint probability. What is the meaning? Probability that two events will both occur, both should be occur. That means A and B. A and means what is the meaning? Intersection, correct? A and B, A intersection B, probability of A intersection B. That means the event A and B both occur together, okay? Or in other words, we can say joint probability is the likelihood of two events occurring together, okay? Or joint probability of a event, joint probability is the probability of an event B occurring at the same time the event A also occurred, okay, the same time A also occur, probability of the event B occurring at the same time A also occur. That means both events occurring together, probability of A intersection B. See in this picture you can see probability of A intersection B. This is the meaning joint probability. That means the probability occurring this intersection portion, occurring, what is the probability of that one together occurring, okay, at the same time that both are occurring, okay. This case, if you want to calculate joint probability, the events must be independent, okay. That means if you want to calculate probability of A intersection B, event independent means what is the meaning? Probability of A intersection B should be equals probability of A multiply probability of B. So if you want to calculate the joint probability, that means the probability of A and B, both events occur together, means how we are calculating? Just probability of A multiply probability of B we are getting. Okay, so this is the idea joint probability. One of those simple example we can discuss that one. See what is the meaning joint probability. Okay, for example, from a deck of 52 cards, the joint probability of picking up a card, just picking up a card that is both red and 6. Okay, what we do, we have a 52 pack of cards, a deck of card having 52 cards. Okay, what is the joint probability? If you are taking one card from out of 52, that card will be both red color and 6 number, both. See, two events occurring together should be red color and it should be number 6. What is the probability of that? This is what we are calling joint probability. Okay, together happening. So what happened actually here? For we are taking A event means getting a red card, because we need red and number 6, correct? So A means getting a red card, B means getting number 6, both we needed, correct? So what is our question? What is the probability that both red and 6? That means probability that red means A, event A, and means intersection. Okay, 6 means B. So probability of A intersection B equal to how much? Probability of occurring together, correct? Both events. So we can calculate probability of A intersection B equal probability of A multiply probability of B. Just now we discussed it. If you want to calculate joint probability, the event must be independent, correct? So probability of A multiply probability of B. Now, what is probability of A actually getting a red card? How many red card we have? 26 card, correct? How many total number of card? 52 card. So 26 divided by 52, correct? Because a deck of 52 card means number of elements of the sample space equal to 52, correct? Because one card only we are taking at a time. Now getting number 6, what is the probability? Probability of B getting number 6. How many number 6 are there? Number 6 cards are there. There are 4 cards, number 6. So 4 divided by how many total number of card? 52. 4 divided by 52, because probability whenever we are calculating, what was we are studied the definition, number of outcomes favorable to that event divided by total number of outcomes in the sample space, correct? So getting a 6 means there are 6 cards are there, number 6 coming, 4 cards are there, divided by total number of card is 52. Now if you are applying here probability of A intersection B, we can calculate probability of A intersection B equals probability of A multiply probability of B, correct? What is the probability of A? 26 divided by 52 multiply probability of B means 4 divided by 52. So what answer we are getting? 1 divided by 26. This is what the joint probability calculation. Hope you understood that one. So two events occur together. Okay, now one more example we can discuss. Example number 3. What is the joint probability of rolling the number 6 twice? Number 6 coming 2 times in a fair 6-sided die. Okay, one die we are throwing. Okay, one die we are throwing 2 times. First time when we are throwing, number 6 coming. Second time also when we are throwing, number 6 is coming. That is the meaning 6 coming twice. Okay, what is the probability that one? We need to calculate that one. What is the joint probability of rolling the number 6 twice? So rolling a number 6 at the first roll, that is the A event. B means rolling number 6 at the second roll. Okay, both should be 6. That is the question. So both should be 6 means what is we need to calculate? Probability of A means first roll number 6. Intersection second roll number 6. So probability of A intersection B equal to how much? Correct? A means the first roll number 6, second roll number 6. So like that, okay, both coming together. What is the probability? So for example, rolling a 6 in the first roll, rolling a 6, number 6 coming in the first roll. What is the probability that one? How many number 6 are there in a die? Only one, correct? Divided by how many total number of elements in the sample space. When we are throwing a die, there are 6 outcomes, correct? So 1 over 6, correct? Because here a die is throwing. So die throwing means how many elements in the sample space? 6 elements. What are the elements actually? Sample space 1, 2, 3, 4, 5 and 6. Correct? So 6 elements. Now rolling a 6 in first roll. Coming number 6 means only one time. Correct? Same like that. B. What is the probability of B actually? Probability of B means getting a number 6 means only one time divided by total number of elements in the sample space means 6. So 1 over 6. So probability of A equals 1 over 6. Probability of B equal to 1 over 6. So probability of A intersection B means probability of A multiply probability of B, that is 1 over 6 multiply 1 over 6, 1 over 36, or approximately we will get this number 0.0277 and 7. Hope you understood the question regarding the joint probability. Correct? Yeah. Now we will go to the exercise questions. So before going to the exercise question, just to remember what are the ideas we discussed now. How to calculate the probability of an event. Probability of an event means number of outcomes in event E divided by number of outcomes in the sample space. Correct? This is what first we are studied. After that we discussed what is the meaning of independent events. Correct? Independent events means probability of A intersection B should be same as probability of A multiply probability of B. Now after that we studied the addition rule. Probability of A union B equals probability of A plus probability of B minus probability of A intersection B. The addition rule we discussed after that. Now we have some other theorems, other rules we are discussed, like probability of A complement. Correct? What is probability of A complement? 1 minus probability of A. After that we are discussed what is the probability of A intersection B complement. Correct? What is probability of A intersection B complement? Probability of A minus probability of A intersection B. Then lastly we discussed probability of A complement intersection B equals. Okay? What is probability A complement intersection B? Probability of B minus probability of A intersection B. So these are the rules we need to memorize here in this exercise 5.1.2. These ideas you can memorize. Okay, now we will go to the exercise. The first question. Okay, so you can see the exercise 5.1.2. Two dice are thrown together. Okay, two dice are thrown together. A and B are two events defined as A event means sum of the numbers on two faces is divisible by 3. Sum of the numbers divisible by 3. B means the sum of the numbers is a perfect square. Two events are defined. Event, okay, A event and B event. Then what we need to calculate? Express A and B as set. Write A set and B set. Find probability of A and probability of B. After that find probability of A or probability of B. Okay, probability of A or B we need to calculate. A or means what is the meaning? Union. Correct? So probability of A union B we need to calculate in the third part. So these are the question we need to do here. So in the first part write A set. A equal to what is that set, and B what is the set B. Correct? Now in the B part, second part, we need to calculate what is probability of A, what is probability of B. Correct? In the third part, what we need to calculate? What is probability of A or B? Or means union. So what is probability of A union B equal to? These are the 3 questions we need to do. So let's start the question. 2 dice are thrown. 2 dice. Okay. What are the sample space we can write first? S equal to sample space. 2 dice will be dice are throwing. Okay. So what are the possibility? Dice possibility means 1 to 6. 1, 2, 3, 4 up to 6. But second die also same 1, 2, 3, 4 up to 6. Correct. So for example, die 1, correct. Second die, okay, die number 2. So first die it is showing 1, 2, 3, 4, 5 and 6, correct. Now second die, for example, first die it is showing 1. Second die, what are the number possibility? 1, 2, 3, 4, 5, 6, any one of the possibility, correct. So here also, if first die showing 2, second die what are the possibility? It will come 1, 2, 3, 4, 5, 6, same like here also, here also, here also, here also, correct, all the way. So how to write the sample space? We can write one by one, we will do. Okay, the 2 dice are throwing. What are the sample space? First die showing 1, second die showing 1, so 1, 1. Same, first die 1, second die 2, 1, 2, then 1, 3, 1, 4, 1, 5, 1, 6, correct. Then what are the other one? 2, 1, 2, 2 will be there, and 2, 3, 2, 4, 2, 5 and 2, 6, correct. Same way 3, 1, 3, 2, 3, 3, 3, 4, 3, 5 and 3, 6. Now we can say 4, 1, 4, 2, 4, 3, 4, 5, 4, 6. Then after that 5, 1, 5, 2, 5, 3, 5, 4, 5, 5 and 5, 6. Then lastly 6, 1, 6, 2, 6, 3, 6, 4, 6, 5 and 6, 6. Okay. So these are the elements in the sample space. Totally how many outcomes are there? Totally you can see how many outcomes will be there. Totally there are 36 outcomes will be there. That means what is the number of elements of the sample space? 36. Okay, there are 36 outcomes. So number of elements of the sample space equal to 36. I hope you understood that one. Now we are defining the event A. What is the meaning A actually? It is given in the question. A means the sum of the numbers on two faces. Okay. For example, first 1, 1, sum of the numbers of two faces. These two number if you are adding 1 plus 1. Okay. It should be divisible by 3. That number, for example, here it is 2. It should be, we can divide by 3. Divisible by 3. That means 2 by 3 is not possible, correct? It will be a point number. So which numbers we can divide by 3 when we are adding these two? That outcome only we are taking. Okay. So here we cannot divide. So we can check that one. Sum of the numbers divisible by 3. That is the meaning A. So we can write sum is divisible by 3. Okay. So what are the elements we can write? This set. For example, each one we can take one by one. Okay. 1 is 2. We cannot divide. 1 plus 2, that is 3. 3 we can divide by 3. Correct. So what is the first outcome we can take? 1, 2. Because 1 plus 2 is 3. 3 divided by 3 is possible. Correct. Because 3 divided by 3, we can get it 1. It is an integer number. Should not be point number. That is the idea here. So 1, 2 we can take. Can we take 1, 3? No, because 1 plus 3 is 4. 4 we cannot divide by 3. 1 by 4, 1 plus 4, 5 we cannot take. Okay, 1 5. 1 plus 5, 6, okay. So 1 comma 5, because 1 plus 5 is 6. 6 divided by 3 means we will get to 2. Correctly we can divide, correct? Now what will be the next one? We can think like that. So 2 1. 2 1 means 3, correct? 3 we can divide by 3. Then 2 4. 6 we can divide. 3 3 we can divide because 6. Then 3 6 we can divide. Then 4 2 we can divide. Then 4 5 9 we can divide by 3. 5 1 we can divide. And 5 4 9 we can divide by 3. 6 3, correct? We can divide because it is 9. Then 6 comma 6, 12. 12 we can divide by 3, 4 times, correct? So these are the numbers. So how many elements we can get it? We can count it. 1 2 3 4 5 6 7 8 9 10 11 12, correct? So we are getting number of elements of the event A equal to 12. Number of outcomes equal to 12 we are getting. I hope you understood that one. How we are taking sum of the numbers, sum of the faces we can divide by 3, okay, from the sample space set. Now what is B actually? B means the sum of the numbers on two faces is a perfect square. What is the meaning perfect square actually? Perfect square I will show here. Perfect square means, for example, square of the number 1. Okay, this is the x number. What is the x square? 1 square is what? 1 itself, correct? What is the number 2 square? 4. 3 number square, what is 9? 4 number square, 16, correct? And 5 number square, that is 23, 25. 5 square is 25. 6 square, that is 36. 7 square, 49. 8 square, 64. 9 square, 81. 10 square, 100, correct? These numbers, see, these numbers we are calling perfect square. Perfect square. That means the square of a number. See, 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, 16, 25, 36, 49, 64, 81, 100. These numbers we are calling perfect square numbers, okay? Like that it is continuing, okay? I am writing some number here. Now, what is our question here? B. B means the sum of the numbers in two faces, okay? For example, if you are taking 1 1, sum of the number 1 plus 1 is 2. Is it a perfect square or not? It is not a perfect square, correct? So if it is a perfect square, that elements you take into the event B, okay? So we can calculate the B event. Sum of the numbers. Numbers means numbers in the two faces is a perfect square. Is a perfect square. So what are the numbers we can take? We can see one by one from here. What is the first case we can take the perfect square? For example, 1 3. If you are taking 1 3, what is 1 plus 2? 1 plus 3, 4, correct? 4 is a perfect square, correct? We shown here, see, the number 4 is a perfect square. So what is the first outcome we are taking? 1 comma 3. Same way, what will be the next one? 2 comma 2, because 2 plus 2 is 4. 4 is a perfect square. Then 3 1 we can take, because 4 is a perfect square. 3 6, because 9 is a perfect square. Then we can take 4 5 is a perfect square. Then 5 4, because 5 plus 4 is 9, is a perfect square. Then 6 comma 3 is a perfect square, 9. So how many elements are there in B? Number of elements of the event B equal to 7 elements are there. Hope you understood that one, correct? So number of elements A equal to 12, number of elements of B equal to 7 elements are there. So this is what our first question. Express the set A and B. Okay, express the events A and B as set. A, find what is the A set and B set. Now we calculated that one, correct? Now we calculate what is the second part of the question, probability of A and probability of B. So here the first part, we did that one. This is the first part of the question, what is A and what is B. Okay, now I am going to do the second part of the question. Okay, part 2, what is probability of A equals and what is probability of B. This is what the second part of the question, probability of A equals probability of A. What is probability of A? What was the rule? Number of elements of A divided by number of elements of S, correct? How many elements in A set? We got it, number of elements of A means 12, correct? So we can write it 12 divided by how many elements in the sample space totally? Number of elements of S equal to 36, correct? So 12 divided by 36. Now probability of B, what is the rule? Number of elements of B divided by number of elements of S. How many elements are in B? 7 divided by total number of elements of the sample space 36. So 7 divided by 36. Hope you understood the first two part. Okay, now the third part of the question. What is the third part? Find A or B. That means A union B. Probability of A union B. That is the third part of the question. Probability of A union B. What was the rule we are studied for this? Probability of A plus probability of B minus probability of A intersection B. The addition rule, correct? Probability of A plus probability of B minus probability of A intersection B. Now out of this, probability of A, this value already we know. What is probability of A? 12 by 36, correct? Here we calculated 12 divided by 36 plus probability of B. This also we know. We just now we calculated 7 over 36. 7 over 36 minus. Now we need to calculate what is probability of A intersection B. This value we are not calculated, correct? Probability of A intersection B. So first calculate what is A intersection B equal. That means A and B, what are the common elements? A set and B set, what are the common elements? This is the A set, correct? And B set, what are the common elements? We need to write that one. So you can compare and write that one. What are the common elements? For example, here see the 3, 6 element is there. 3, 6. This is also coming in B. See 3, 6. Correct? Now 4, 5. 4, 5 is coming in B and A common. 4, 5. See here you can see. Now what is else? 5, 4. 5, 4 is coming and 6, 3 also common. 5, 4 and 6, 3 you can see in B also. See 5, 4 and 6, 3. Correct? So I can write A intersection B equals first 3, 6, then 4, 5, then 5, 4, then 6, 3. Correct? A intersection B. So how many elements are there? Number of A intersection B. Number of A intersection B means 4 elements. Correct? 4 outcomes are there. Number of A intersection B equal to 4. So number of A intersection B 4 means what is the probability of A intersection B? Probability means what you do? The number divided by total number of elements in the sample space. Correct? That means number of elements of A intersection B divided by number of elements of the sample space. What is the number? 4 divided by how many elements in sample space? 36 elements. Correct? Now this number we can apply here. Okay? Probability of A intersection B means 4 divided by 36. Now you can use the calculator. You will get the answer 5 divided by 12. Hope you understood this question. Okay, how we are getting probability of A union B. So here we defined S, first we are written, then defined the A event and B event. We are calculated what is probability of A, what is probability of B. After that, probability of A union B here. Hope you understood that question. Okay, now we will go to the question number 2 here. Okay, question number 2. What is the question number 2? If A and B are two events, if A and B are two events, such that probability of A equal to 1 by 4. Okay, probability of A equal to 1 over 4 and probability of B equal to 1 over 2 already given in the question, and probability of A and B, and means intersection. Okay, so probability of A intersection B equal to 1 over 8 already given. The first question we need to do, first question is probability of A or B, or means union. Okay, so probability of A union B equal to how much? This is the question. Okay, so first part we can do, we need to calculate probability of A union B, correct? So probability of A union B, just now we written the rule, probability of A plus probability of B minus probability of A intersection B, correct? What is probability of A given in question? 1 over 4 plus what is probability of B? 1 over 2 minus what is probability A intersection B? 1 over 8. You can use the calculator. Okay, you will get equal to 5 over 8. Hope you understood the question. Probability of A union B equal to 5 over 8. Okay, now what is the second part of the question we need to do? Probability of not A. Not A means A complement. Probability of A complement. Not means complement. And here and means intersection. Not B. Not B means B complement. Probability of A complement intersection B complement. That is the meaning of not A and not B. Okay, this is the second part of the question we need to do. Okay, so I will do that second part. Probability of A complement intersection B complement. Okay, so we are using just De Morgan's rule here. Complement, both complements are coming means what we can write, probability of A. Okay, you can see a simple way like this, you can understood the rule. Here complement is there, here complement is there, correct? So both we are taking outside the bracket, that is complement. What is balance? A same, B also there. Now here, okay, intersection is there. Intersection just reverse. If intersection coming, you can write union. If it is union, you can write like intersection. This idea. Okay. So A complement already we are taken. So A intersection we can write it as union. Okay, and B. So probability of A union B all complement. Okay, just we are applying the rule only, that one complement we can take it out like probability of A union B complement. Now, okay, now you can see we studied one rule, probability of A complement. What we written? 1 minus probability of A, correct? Remember this rule. So here also the same rule we are applying. What we do? Probability of A union B complement. This all complement if we are deleting, what we do? Just take 1 minus probability of A union B. Complement, okay? Complement when we are deleting, total minus that without complement term. 1 minus probability of A union B. Okay? If you are deleting complement, take 1 minus. See 1 minus probability of A union B. Now apply the values. Equals 1 minus what is probability of A union B? Here we are calculated 5 divided by 8, correct? So 1 minus 5 divided by 8. So that you can check the answer. You will get 3 divided by 8. Hope you understood this question. Okay, now we will go to the third part of the question. What is the third part? Probability of not A. Probability of not A means A complement. Or means union. Not B. Not B means B complement. Okay. This is how much? This is what the third part of the question. Probability of not A union, or means union, not B means B complement. So we can go to the third part of the question. Probability of A complement union B complement. Here also same rule we are using, De Morgan's law. So in simple way we can study like this. Here complement is there, here complement is there. So probability of complement we are writing out like this. What is balance you can see here, A is there, union becomes intersection, okay, just opposite, intersection, and B, probability of A intersection B complement, probability of A intersection B complement. Now what I told, as I told you, delete this complement. What we do, 1 minus, correct, probability of A intersection B, 1 minus, once you are deleting complement, take 1 minus probability of A intersection B, that is 1 minus, what is probability of A intersection B given in the question, 1 over 8, correct. So 1 minus 1 over 8, so what will be the answer, equal to 7 over 8. Hope you understood. Now we will go to the fourth part of the question. What is the fourth part? You can see probability of A intersection B complement, probability of A intersection B complement. Now I will do that question, the fourth part, probability of A intersection B complement equal to, okay. So this one we are studied one rule, this section. What is probability of A intersection B complement? Probability of A minus probability of A intersection B, correct, the direct rule here. That means equal to, what is probability of A given in the question, 1 over 4 minus probability of A intersection B given in the question, 1 over 8. You can use the calculator, you will get 1 over 8. So this is what the answer that question. So idea is easy, but we need to clear that rules. Okay, now we will go to the third question. Okay, question number 3 here. One number, okay, just I am underline that word, one number, because there is more importance this word, one number. How many number? One number. One number is chosen random from the numbers 1 to 50. Okay, 1 to 50. That means our sample space is the number from 1 to 50. 1, 2, 3, 4, 5, 6, 7, 8, up to which number? 50, 49, 50, like this. Okay, this is our sample space. So one number we are choosing from here at random. Okay, that means how many possibilities are there? Number of elements of S equal to, there are 50 number. So one number choosing means there are 50 possibility, 50 numbers are there, correct. Now what is the question? Find the probability that chosen number is divisible by 5. Chosen number is divisible by 5. Okay, what is the probability that? So what we are doing is we are just defining one event A. What is event A? Divisible by 5. Chosen number is divisible by 5, correct. So number is divisible by 5, correct. Number is divisible by 5. So what are the number divisible by 5 from 1 to 50? We can see what are the number divisible by 5. Which number we can divide by 5? 1 can be divided by 5? It will not. Point number, correct? No. So 2 can be divided by 5? No. 3? No. 4? No. 5 we can divide. Then which will be the next number? Just multiples of 5 we can write. 5, then 5 plus 5, 10, 10 plus 5, 15, 15 plus 5, 20, correct? Then 25, 30, 35, 40, 45, and 50, correct? These are the numbers divisible 5, correct? How many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, correct? So number of elements of A means how much? Equal to 10. How many numbers? 10 numbers, correct? A number of A equal to 10. Number of favorable outcomes to the event A equal to 10. Correct? Now what is our question? Find the probability that chosen number is divisible by 5. That means we need to calculate what is probability of A. Correct? Probability of A equals. That means probability of chosen number divisible by 5. Number divisible by 5 means we are represented by A. So probability of a number divisible by 5. Correct? Probability of a number divisible by 5. Correct? So what is the rule finding probability? Number of elements of A divided by number of elements of the sample spaces. How many number of elements of A? 10. Divided by how many elements in the sample space? We have 50 elements. So what will be the probability? 1 divided by 5. You can check by calculator that one. Hope you understood that question. Now let me go to the fourth question. Almost same model question. You can check. A number, just underline that word, A number, one number, okay. A number is chosen at random from the first 30 positive integers. What are the first 30 positive integers? S equal, sample space equal, positive numbers from 1 to 30. So 1, 2, 3, 4, 5, 6, 7, up to 30, 29, 30, correct? First 30 positive integer, 1 to 30 number. Now, what is the question? Find the probability that chosen number is divisible by 4 or by 6. Okay, so what we do? Just take A. Take A. A means what is the number? Chosen number divisible by 4. Okay, and take B. B means chosen number is divisible by 6. Okay, we can divide by 4 and we can divide by 6. That is the meaning. So there are two events are there. Two events are there. One is divisible by 4. Another one is divisible by 6. So divisible by 4 we are taken A. Divisible by 6 we are taken by B. Okay. Now we can write this set here. What is the A set? Number divisible by 4 means, what are the number divisible by 4 here? That means we can divide by 4. Just write 4 number multiples. 4 we can write. 4 plus 4, 8. 8 plus 4, 12. 12 plus 4, 16. 16 plus 4, 20. 20 plus 4, 24. 24 plus 4, 28. Then next 32, it will not come here. Maximum 30 only. Correct? So here how many elements are there in A? Number of elements of A equals, how many number? You can check it here. 7 numbers. Correct? Now divisible by 6. What are the number divisible by 6? Multiples of 6. So 6 plus 6, 12. 12 plus 6, 18. 18 plus 6, 24. 24 plus 6, 30. So how many numbers are in B? Number of elements of B equals 5 numbers. Correct? So A set we got, B set also we got, number of elements of A we got, number of elements of B also we got. Yes. Now what is the A intersection B? We can just calculate. What is A intersection B? Correct? A and B common numbers. What are the common numbers in A and B? You can check the number. 12 is common. 12 here. Here also 12 is common. What is other number? 24. 24 here also there. Here also there. So we can write A intersection B means 12, 24. Correct? So how many elements are there? Number of elements of A intersection B equal to 2. Correct? Now we are coming to the question. What is the question we need to do? Find the probability that chosen number is divisible by 4 or divisible by 6. Divisible by 4 means A, correct? Or means what is the meaning? Union. Divisible by 6 means B, correct? So what probability we need to calculate in our question? Probability of A union B. That is the question, correct? So I am answering the question now. Probability of A union B equal to. Correct? That means probability of A means divisible by 4. Union means or. Divisible by 6. Correct? Probability of A union B. What is the rule? We are studied probability of A union B. Probability of A plus probability of B minus probability of A intersection B. Correct? So numbers apply. What is probability of A? Here we got probability of A means number of elements of A divided by number of elements of S. What is the number of elements of A? 7. Divided by what is the total number of elements in the sample space? It is 30. Correct? Because we have 30 number of elements of S here. Number of elements of S means 30 numbers. So 7 by 30 plus probability of B. How many number of elements of B? 5. Divided by total number of elements 30. Correct? Minus probability of A intersection B. Number of A intersection B is 2. Divided by total number of elements is 30. Correct? 2 divided by 30. Now when we are calculating, we will get 1 divided by 3 is the answer. 1 over 3. Hope you understood this question. 1 over 3. So that is the question. Number divisible by 4 or divisible by 6. Divisible by 4 means A, or means union. Divisible by 6 means B. So you can get it this answer. Now I will go to the question number 5 here. You can see question number 5. A card, just underline that word, A card, one card. Okay, A card is drawn from a deck of 52 cards. How many cards are there totally? 52 cards. So we can write number of elements of the sample space equal to 52. Correct? Because A card, one card we are selecting from 52 cards. So how many outcomes we are getting? 52 outcomes we are getting. Correct? So number of elements of S equal to 52. Now what is the question? Find the probability. We need to calculate the probability that the card will be a diamond card. Okay, a diamond card means we will take A. Okay, so probability of A first we need to calculate in the first part. So just to take A. A means a diamond card. First we need to calculate probability of a diamond card. Correct? How many diamond card will be there? Number of elements of A. How many diamond cards are there? There are 13 diamond cards. Correct? You remember that picture? Totally 13 diamond cards are there. So what is the probability of a diamond card? Probability of A equals number of elements of A divided by number of elements of S. Correct? That means number of elements of A means 13. Total number of the sample space, total number of cards means 52. 13 divided by 52. Hope you understood. Now, so this question part A we are doing probability of A equal to how much was the question. Now not a diamond. Diamond means A. So not diamond. Not means what is the meaning? Not complement. So A complement we need to calculate. Not a diamond. Correct? Not a diamond card. What is the probability? This is the second part of the question. Okay. So I will go to the second part now. The second part of the question. Okay. Not a diamond. So for example B I am choosing. Not a diamond. Okay, how many cards not a diamond it will be there? Number of B. Not a diamond card. There are totally 52 card. Correct? Totally 52 card we have. Out of that 13 is diamond card. So not a diamond means 52 minus 13. Correct? 39 will be there. Correct? So number of B means 39 we will get it. 39. So what will be the probability of B? Probability of B means number of elements of B divided by number of elements of S. Correct? You can check it. That is 39 number of elements of B divided by 52. Hope you understood that question. Okay, not a diamond card, correct? Now, okay, before going to the second one, okay, we can do the same question. No, we can do in another way also. This one, not a diamond card. As I told you, a complement. So here probability of a complement is the question, correct? Otherwise, we can do like probability of B. If you are taking this as B, you can do probability of B. Otherwise, probability of A complement also. If you are doing probability of A complement, the same question, how can we do probability of A complement? I am doing here. This way also okay. 1 minus probability of A, correct? 1 minus, already we did here, probability of A, 13 by 52. We will get the same answer, this answer 39 divided by 52. Okay, so this way also we can do, up to you, that one. Okay, now we will go to the third part. What is the third part of the question? What is the probability of getting an ace card? C, I am taking it as ace card, okay, C. So for example, third part, C means an ace card, so how many elements in C? Number of C. How many outcomes favorable to C? How many ace cards are there? There are 4 ace cards, correct? So what will be the probability of C? Probability of an ace card means 4 divided by totally how many? 52 cards. 4 divided by 52. That is easy idea. Now a black card, I am taking it as D, black card. Okay. So fourth one, D, a black card. So how many black cards are there? Number of D, number of black cards, number of outcomes favorable to D. Number of black cards, how many black cards we have? We have 26 black cards are there, correct? So what is the probability of D? Probability of a black card equal to number of D divided by number of S. So 26 divided by 52, correct? You can use the simplification, you can do by calculator. Okay, 26 divided by 52. Hope you understood this question, getting the different cases. Okay, now we are going to question number 6. The same idea whatever we did before question. A card, you can underline that word. One card only we are choosing out of 52 cards, correct? A card is drawn from a deck of 52 card. That means number of elements of the sample space equal to 52, correct? Now find the probability. We need to calculate the probability of getting a queen card. So the first part I am taking as A. A means getting a queen card, correct? How many number of elements of A? How many queen cards are there? 4 queen card, correct? So what will be the probability of A? Probability of A equals number of elements of A divided by number of elements of S, correct? So how many will get it? Number of elements of A, number of queen cards are 4 divided by total number of cards equal to 52, correct? 4 divided by 52. If you are using calculator, you will get 1 over 13. Both are same, 1 over 13. Okay, now the second one. What is the second part of the question? A queen or a heart. Queen card we are taken A. Or means union. Heart card, correct? Union, heart card. Heart card I am taking as B. Okay, a queen or heart. That is the question. So I am taking B. B means a heart card, correct? So how many elements in B? Number of elements of B. Getting a queen, heart means how many heart card will be there? 13. So what is the probability of B? Probability of B equals 13 divided by total number of card 52. 13 divided by 52. I hope you understood that one, correct? Now we will come to this question. Probability of a queen or a heart. Okay, I can show The question, probability of a queen or a heart. Probability of a queen or a heart. Okay. Now, what is that one? Equal to probability of queen means what symbol we are used? A. Or means union. Heart means B. Probability of A union B. What is the rule for probability of A union B? Probability of A plus probability of B minus probability of A intersection B. Correct? Probability of A intersection B equal to. Now, probability of A we calculated in the first part, 1 over 13, plus probability of B we are calculated in second part, 13 divided by 52. 13 divided by 52 or 1 over 4 also okay, minus probability of A intersection B. A intersection B, what is the meaning? I am writing here, okay, A intersection B. What is the meaning A intersection B? A means a queen card, correct? A queen. Intersection means and. B means a heart card, correct? A heart card. So, queen and heart. Queen and heart. How many cards are there? Queen and heart. Number of A intersection B. You remember that one. Queen and heart. Queen symbol should be there and heart symbol should be there. How many cards? Only one card, correct? So what will be the probability of A intersection B? Means 1 divided by total number of card 52. 1 divided by 52, correct? So that number we need to apply here, minus 1 divided by 52. Okay, now you can check the answer by calculator. You will get 4 divided by 13. Hope you understood that one. Only here, see the picture of the cards. You can see queen and heart, only one card. Queen symbol and heart symbol, only one card. So 1 divided by 52, A intersection B. So you will get 4 divided by 13. This is the idea of that question. Okay, now let me go to the question number 7 here. Okay, question number 7. Now the questions are little different. You can see question number 7. 2 cards are drawn. How many cards? Not 1 card. 2 cards are drawn, a 52 card, pack of 52 card. 2 cards, not 1 card. 2 cards are drawn from a pack of 52 card. What is the probability that the card drawn are both spades? Both cards are spade. 2 cards we are choosing. Okay. 2 cards like this, 2 cards we are choosing from 52 cards. These find the probability that both cards should be spade card. This should be spade and this should be spade. Both cards should be spade card. What is the probability? This is what our question. So here when we are doing 2 cards from 52 card, how many ways we can choose? That is the number of elements of the sample space. Okay, so that one first we need to be careful. So I can write here total number of ways. Total number of ways of selecting 2 cards. Okay, from 52 cards, correct? From 52 cards equal to, that means we need to choose. We need to choose or select. Choose or select means combination. Okay, select or choose means, what is the meaning? Combination. So 2 cards we are selecting from 52 card. How many ways? Combination of 52, 2. Correct? Out of 52, 2 taking at a time. So this equal to, you can check by calculator, 13 to 6, 1326. We have studied this idea in module 3. Module 4. Okay, 1326. This is the number of elements in the sample space. Okay, number of elements of the sample space equal to 1326. So whenever we are doing question, how many cards, okay, we are selecting, this is important. 2 cards means we need to apply the combination. 1 card means no problem, but 2 cards means we need to apply the combination. 2 card, 3 card, 4 card, like that. Okay, we need to be combination. Now what is the event A we are selecting here? A means, what is the event? 2 cards we are selected, both should be which type of card? Spade card, correct? So both should be spade. Okay, so getting 2 spade card, correct? Getting 2 spades, both are spade means getting 2 spade card. Okay, so you can see how many spade card we have totally? 13 spade card. So we need 2 spade card, correct? So how can we write that one? You can, I will write here the reason. We have 13 spade cards. Okay, out of this 13 spade card, how many we are taking at a time? 2 at a time, because 2 cards only we are choosing, correct? So how many elements in number of elements of A? Number of elements of number of ways, 2 spade card selection, correct? It is the combination of, from 13 spade card we are choosing 2 at a time. Because why we are selecting 13 2? Because we need both spade card. Both, if you want spade card means how many spade card we have? 13 spade card. So taking the combination of 13 spade card 2 at a time, correct? So 13 2. So what will be the answer? 78. Okay, this is the more than 2 or more than numbers coming means we need to take always the combination. Okay, that is what that important. So number of A equal to 78 we are getting. Now we can calculate the probability. What is our question here? Probability of card drawn both spade, correct? Both are spade. Both are spade card. That means 2 spade card equal to, that means probability of both are spade card, probability of A. This is what our question, getting 2 spade card equals number of elements of A divided by number of elements of S, correct? What is number of elements of A? 78 divided by number of S means 1326. So when we are using calculator, you will get 1/17. So this is the answer. Hope you understood that question. Now question number 18. Sorry, 8. Question number 8. We are going to question number 8 now. From a pack of 52 cards, 3 cards. See, this is what important word. 3 cards are drawn at random. I told more than 2 or more than 2 means. 2 or more than 2 means always we need to use combination. So 3 cards we are choosing. First card, second card, third card. Okay, 3 cards we are choosing from 52 cards. Okay, so how many ways we can choose? We can write first total number of ways of selecting, total number way of selecting 3 cards, correct? We need to choose 3 cards from how many cards? Totally we have 52 cards. From 52 cards, okay, equals, that means number of elements of the sample space equals combination of totally 52. How many we are selecting at a time? 3. So you can check the answer in calculator. 22100. This one we are getting. Okay, total number of elements of the sample space. Now we can read the question. How many? This is the first part of the question. How many ways can 3 cards be drawn? How many ways 3 cards be drawn? Okay, 3 cards from 52. How many ways we can draw? That is what combination of 52, 3. That is the first part of the question. Number of elements of the sample space. Now second part of the question. What is the second part? Find the probability. We need to calculate the probability that the card drawn contains exactly 2 aces. Okay, 3 cards we are selected. Out of that one, 2 card will be ace card. This is ace card. This is also ace card. This is any other card, no problem. Okay, other card. So exactly 2 aces means should be 2 aces, not more than or less than. 2 aces should be there exactly. So what is the probability of that one? Okay, so that is the question here. So we can do here. See, I am defining one event A. What is the event? Exactly 2 aces, ace card, exactly 2 ace card. So exactly 2 ace card means what is the possibility, students? Possibility, correct? What are the possibility actually? 2 ace card, correct? A means ace card, okay? 2 ace card and one other card, because we have totally selected 3 cards, correct? So 2 out of this 2 should be ace card. So 1 should be any other card. That is like that, okay? Now, what is the number of elements? How many ways we can select like this? That is the question. So number of elements of A equal how many ways we can select 2 ace card and one other card. Okay, 2 ace card. How many ace card we have totally? 4 ace card. From 4, how many we need to select? 2 ace card. So how many ways we can select? 4C2, correct? 4C2 ways we can select. Okay, you can just note here. We have totally 4 ace card. Okay, I will note here 4 number of ace card. Number of ace cards are 4. Okay, so out of that 2 selecting, so 4C2. Now one card from other card other than ace, one card we need to select. Ace should not be, because exactly 2 ace only we needed. So other than other cards we need to select one card. So other than ace card means how many cards will be there? Total we have 52 card. So other than ace card, correct? Totally we have 52 card. Out of this ace card subtract. So for 52 minus 4, how many card will be there? 48. From this 48, how many cards we need to select? We need to select one card. So what we do? 48 combination 1. So what is the total number of A? Just a multiplication rule you can use. We studied in module 4 this one. So number of elements of A equal to 4C2 multiply 48C1. So what will be the answer we get? 288. Okay, so this case careful. We are selected 3 cards, but 2 ace and one other card. 2 only ace. So 4C2, from 4 ace card 2 we are selecting, and 48 other card, because 48 plus 4 means 52. So 48 other card other than ace card, 48 card, from that one we are selecting. So 48 to C1. So 288 totally we are getting. Now we will go to the probability. Find the probability that card drawn exactly 2 aces. Now we can calculate probability of A equals. So probability of A equal, that means probability of exactly 2 aces. Exactly 2 aces equals probability of A, that means number of elements of A divided by number of elements of S. Number of elements of A means 288 divided by number of S we got 22100, correct? So we will get 72 divided by 5525. This is the question here. What is the probability of exactly 2 aces? So we will get this one, 72 divided by 5525. Hope you understood that question. Now we will go to question number 9 here. Question number 9. You can read the question. A class of 10 boys and 6 girls. Okay, in a class there are 10 boys and 6 girls. Okay, we have 10 boys and 6 girls are there. So totally how many students are there? 16, correct? Totally 16 students. 10 plus 6, 10 boys plus 6 girls, 16 students are there. If a committee of 3, that is what important, how many we need to select? 3. A committee of 3 are chosen. a committee of 3 are chosen random from the class. Find the likelihood that 3 boys are selected. That 3 students selected means 3 are boys selected. Second part, exactly 2 girls are selected, like that. 2 cases we need to calculate the probability here. Okay, so likelihood means the probability, possibility based on the observed parameters, observed conditions. Okay, so both are the prediction, both we are doing prediction, probability and likelihood, both we are doing prediction. Probability, it is referred to chance, likelihood means referred to the possibility. Okay, so from this possibility we need to find the probability value, correct? So a class of 10 boys and 6 girls, totally 16 students, a committee 3 chosen. So first we need to calculate number of elements of the sample space, correct? So we can write total number of possible committee, correct? Possible committee. How many members should be in that committee? 3 member. Equals, okay, how many students totally? Totally we have 16 students, correct? Out of that, how many students should be in one committee? 3 member. So how many combination we need to get it? Combination of 16 comma 3, correct? So you will get 560 combination we will get it. So this is the number of elements of the sample space. Total students 3 taking at a time, 3 students we are taking at a time. So total number of elements of the sample space equal to 560. Number of outcome favorable to the sample space equal to 560. Okay, now we will come to the first part of the question. Okay, A, we are giving the event. What is the first question? Find the probability. 3 boys are selected. 3 boys. Out of these 3 students selected, 3 should be boys. That is the meaning, 3 boys are selected. So what is the probability of that? Okay, so capital A, we are selecting the event that have 3 boys, correct? 3 boys are selected. 3 boys are selected. That means, what is the meaning? We have 3 boys in that committee and how many girls? 0 girls, correct? Because totally 3 students. So 3 boys means there should not be any girl there, correct? 0 girls, that is the meaning. So what we can say, what is the number of elements of A? We can select a number of possible committee having 3 boys, correct? So number of A equal, how we are calculating? 3 boys we need to get it. How many boys we have? 10 boys. So from 10, 3 selecting means 10C3, correct? 10 boys, 3 combination we are selecting. Multiply, how many girls we needed? 0. How many girls we have? 6. So from 6, 0 we are selecting. 6 is 0. 6 0 means 1 should be. So totally we will get 120. Okay, 120 ways we can select. 6C0 means answer is 1. So if you are writing or not writing, no problem. But 10C3 multiply 6C0. 3 boys. So 3 boys means 3 boys and 0 girls, because the committee having 3 member. Okay, totally. So 120 we are getting. Now you can calculate the probability easily, correct? So calculate what is the probability here. Probability of A equals, probability of A equal, that means probability of A means, what is the meaning? Probability of 3 boys were selected, correct? Probability of A equals number of elements of A divided by number of elements of S. We can write the answer. What is number of elements of A? 120. Divide number of elements of S, 560, correct? 560. 120 divided by 560. Approximately you will get 0.214 like this. Okay, approximately I am writing. So this is the first part of the question. Now I am going to the second part of the question. Okay, second part of the question. What is the second part? Out of 3 committee members, exactly 2 girls are selected. Exactly 2 girls means 2 girls only, correct? 2, not less than 2, more than 2, exactly 2 girls. 2 girls will be there, are selected out of 3. So I am writing the event B. B means exactly 2 girls, correct? Exactly 2 girls are selected. Okay, event that exactly 2 girls are selected. So 2 girls means what are the possibility? 2 girls will be there. How many boys? 1 boy, correct? Because 3 member in the committee, so 2 girls should be there and 1 boy should be there, correct? So that is the meaning, exactly 2 girls. So what is the number of elements of B? How many ways we can select like that? Number of B equal 2 girls, correct? How many girls we have totally? 6 girls. So 6 combination 2 multiply 1 boy also needed. How many boys we have? 10. So 10 C1, correct? So totally you will get 150. 150 ways we can select like that. So you can find the probability of exactly 2 girls. Exactly 2 girls. This is what our question. Probability that exactly 2 girls equal to number of elements of B divided by number of elements of S, correct? What is the number of elements of B? That is 150 divided by number of elements of S means 560, correct? Or you can write 15 divided by 56, or approximately you will get 0.26787 like this. Okay, approximately. So this is the question here. Hope you understood the question, both the question. Exactly 2 girls, what is the probability? 3 boys, what is the probability? Okay, now let me come to the question number 10 here. You can read question number 10 now. A box contains, okay, a box containing 4 defective and 11 good bulbs are there. A box containing 4 defective and 11 good bulbs are there. So I can write here 4 bulb defective, 11 bulb good bulb. Okay, so totally how many bulbs are there? There are 15 bulbs are there, correct? Totally 15, 4 plus 11. 4 defective bulb, 11 good bulb, 15 bulbs are there. Now 2 bulbs are chosen. This is what important. How many bulbs we are taking? 2. Should be combination, correct? So out of 15 bulb, 2 bulb we are selecting. So what is the first part of the question? How many ways 2 bulbs can be drawn? 2 bulb from 15, how many ways we can drawn? That is the first question. Okay, so we can write total number of ways. Total number of ways 2 bulbs can be drawn equal to, out of 15, 2 bulbs, combination of 15, 2. You can check by calculator, 105. This is the number of elements of the sample space equal to 105. Hope you understood. Now the second part of the question. Okay, we will go to the second part. What is the second part? What is the probability that both bulbs are good? Okay, how many bulbs we are selected? 2 bulb. Both bulb should be good bulb. What is the probability? Okay, so A means the event A. What we are telling? Both bulbs are good, correct? Both bulbs are good bulbs, correct? So both bulbs are good means what is the possibility here? We can write both bulbs are good. That means 2 bulb only we are choosing. 2 are good, correct? 0 defective. That means defective nothing we are selected. 0 defective. 2 good and 0 defective. So what is the number of outcomes of A? How many ways we can select like that one? 2 good bulb. How many good bulb we have? 11. So from 11 combination 2 we are selected, correct? Multiply 0 defective we are selected, that part no need to write. 4 defective is there, 0 we are taking, 4C0. So you will get the answer equal to 55, correct? 55 we are getting. Now we can calculate what is the probability here, correct? So I can write here, I can go to the next page. So probability of A equals, probability of A means probability of both are good, okay, equal to number of elements of A divided by number of elements of S. Number of elements of A means 55, number of S we got 105, correct? Or equal to 11 divided by 21, you will get it. This is the first part of the question, okay? Number of elements of A, this one 55 divided by total number 105. Okay, now let me go to the second part. What is the probability that both bulbs are defective bulb, okay? Both are defective, that is the event. So we are going to the third part. We define an event B. What is the event? Both bulbs are defective. Both bulbs are defective. So actually what is the possibility? Both bulb, only 2 we are selected, both are defective. That means 2 defective bulb, but how many good bulb? 0 good bulb, correct? So what is the number of elements of B? How many ways we can select like that? Number of B equals 2 defective out of how many? 4. Totally we have 4 defective bulbs are there, correct? So 4 combination 2 multiply, correct? How many good bulbs are there? 11. How many we are selecting? 0, nothing selecting. So 11C0. So totally how many will get it? 6. Okay. Then we can calculate the probability now. Probability that both are good, both are defective. Probability of B. Probability both are defective equal to number of elements of B divided by number of elements of S. Number of B means 6 divided by number of S means 105. So you will get the answer 2 divided by 35. Hope you understood this question. Okay, combination questions, whenever it is there 2 or more we are selecting, that is the combination related questions. Okay, now question number 11, you can read question 11. 3 balls, okay, this is the highlight. 3 balls are drawn at random from a bag containing 5 red and 4 black balls are there. Okay, we have 5 ball red and 4 ball black balls are there. That means totally 5 plus 4, 9 balls are there. Okay, so from these 3 balls we are selecting, from 9 balls 3 balls we are selecting at random. Okay, so what is the total number of ways we can select? Total number of elements in sample space, total ways, total number of ways 3 balls are choosing equals 9 total balls. Out of that how many we selected? 3 at a time, combination of 9, 3. So equal to 84. This is the number of elements of the sample space, total number of outcomes favorable to the sample space, correct? Total number of outcomes in the sample space, 84. Now we can go to the first part of the question. What is the first part? All the 3 are red color balls. 3 balls we are chosen already, that all 3 are red color. That is the question. All 3 balls are red color. So we can define the event A like all 3 are red, correct? All 3 are red. That means what is the meaning? We are getting 3 red balls and 0 black balls, correct? Because 3 only we are chosen. All 3 red means 3 red but 0 black color balls. So what is the number of A? How many ways we can choose like that? 3 red. How many red we have? 5. So 5 combination 3. Multiply 0 black means from 4C0, correct? 4C0, 0 coming means that will be number 1 in calculator. So 5C3 only the answer. So equal to 10. Okay. So you can write the probability now. Probability that probability all are red, all three are red. That is probability of A equals number of A divided by number of S. What is the answer? 10 divided by 84. That means 5 divided by 42. From calculator you will get 5 divided by 42. Hope you understood. Okay, now we will go to the second one. All three are black color. What is the probability? 3 balls we are selected. All 3 are black color balls. Okay, that is the second part. So I am taking the event B. What is the event B? All 3 are black. Correct? That means how many balls? 3 black balls, correct? But how many red balls? 0 red balls, nothing, correct? So number of elements of B equals, how many black color totally we have? Actually 4, correct? How many black color? 4. So from 4, how many we are selected? 3. So 4C3 multiply, how many red we have? 5. How many we selected? 0. So totally how many ways we can select like this? Equal to 4. Okay. So what is the probability that all 3 are black? Probability of B equals number of elements of B divided by number of elements of S. Number of elements of B means 4 divided by number of elements of S means 84. So you will get 1 over 21. Hope you understood the second part. Now third part of the question. What is the third part? 2 are red and 1 is black. 3 balls we are selected. 2 red ball and 1 black ball. What is the probability? Okay, 2 red and 1 black. So we can define C as 2 red balls and 1 black ball and 1 black ball. Okay, so what is the possibility? 2 red and 1 black, correct? So how many ways? Number of C equal number of the outcome favorable to the event C equals 2 red. How many red do we have? 5. So 5C2 multiply 1 black we need to select from 4. So 4C1. You can check the number, you will get 40. Okay. Now you can calculate the probability. So probability of C equals number of C divided by number of S. Number of C means 40 divided by number of S means 84. So that you will get 10 divided by 21. So that is the answer here. Hope you understood this question. Okay, now let me go to the next question. Question number 12 here. Another important question. Question number 12. What is the probability that a leap year will have 53 Sundays? What is the probability that a leap year will have 53 Sundays? That is the question. In a leap year, 53 Sundays coming, what is the probability? Okay, so we will do that one. Okay, so before that, some prerequisite idea, see leap year. See, for example, 2024 is leap year. Leap year means February 29 days will be there. That is the meaning leap year, correct? So normally 1 year means 365 days, correct? Normal year means 365 days will be there, correct? But leap year, how many days will be there? 366 days will be there, correct? Now, when we are coming to the question, See this leap year, you can see how many Sundays are there. See like this 1, 2, 3, 4, like totally how many Sundays are there you can. So 53 Sundays coming, what is the probability? That is the question. Okay. So when we are coming to the question, just I am writing number of days in a leap year. How many days are there in a leap year? 366 days, correct? Now, how many weeks we can calculate now? How many weeks will be there in an year, correct? So I am just writing here number of weeks per year. Just clear the situation. Number of weeks per year means 366 divided by 7, correct? 1 week means 7 days. So if you are dividing 366 divided by 7, you will get how many weeks, correct? So how many weeks will be there? There are 52 weeks, correct? Plus 2 days extra will be there. 2 days extra, correct? Like this in the calendar you can see 1 week full will be there. After that some days extra will be there. See here 3 days extra is there. Okay, like 2 days extra will be there. How we are getting this? You can check by calculator. 366 divided by 7. Okay, if you calculate 366, see I can show here 366 divided by 7, correct? You will get like in calculator 52.28571429 like this, correct? What is the meaning of this one? There are 52 week. This is the week, correct? And how many days extra here you can see? This many days. Okay. This number if you multiply with that one, you will get how many days extra will get. 2 days will be the extra. That means you can see 52. For example, you can understood like this. 52 week, correct? I will show here this 52. 52 week means 52 multiply 7, that means 364 days. So plus, correct? Here how many days extra I am taken? 2 days extra, correct? So how many days we will get it totally? 364 plus 2 days means how many we will get? 366 days we will get it. Okay, 366 days we will get it. That is what I wrote here. 52 weeks we will get it and 2 days extra will get it. Okay, in an year I am telling 52 weeks correctly it will come and 2 days extra will come. Okay, why we are doing, you will understood one after one or two lines why we are doing like this. So number of weeks per year means 52 weeks and 2 days extra will be there. Now 52 weeks means how many Sundays and how many Mondays and how many two days? Each week one Sunday, one Monday, one Tuesday, Wednesday, Friday, Saturday, all are there, correct? All 7 days will be there. So 52 weeks means we have 52 Sundays, correct? 52 Sundays and 52 Mondays and 52 Tuesdays like that. Each week one Sunday will be there. So 52 week means 52 Sundays will be there, 52 Mondays will be there, 52 Tuesday will be there, all days, correct? Like that. So I am just writing here only Sundays because our question is depends on our Sundays. 52 Sundays, 53 Sundays like that, correct? So 52 week means 52 Sundays will be there. Now in these 2 days, correct? And extra 2 days will be there. These 2 days, what are the possibility? Depends on, we can say 53 Sunday, what is the probability, correct? So these 2 days, what are the outcomes? We need to write that one. Okay, 52 Sunday by default it is there already in a leap year, correct? Because 52 week is there, so 52 Sunday by default it is there. Now these 2 days, what are the possibility? Okay, so we will see that one. So total outcomes with the remaining 2 days, equals, what are the possibility that 2 day? That 2 days either it will be Sunday and Monday, correct? Or it will be Monday and Tuesday, or it will be Tuesday and Wednesday, correct? Or Wednesday and Thursday, correct? Or Thursday and Friday, okay? And Friday, Saturday sorry, and Sunday, Saturday and Sunday. These are the possibility. Remaining 2 days, 52 Sunday by default is there. Another 2 days, one of these two, correct? One of the outcome will be there. Either Sunday, Monday will be there that 2 day, or Monday, Tuesday, or Tuesday, Wednesday, or Wednesday, Thursday. Thursday also I am representing T letter. So Thursday I am putting S here. Thursday, Friday, and Friday, Saturday, Saturday, Sunday, correct? Now, so I hope you understood that one. So how many elements are there here? Number of elements, it is equal to number of elements of S equal to 7, correct? This is the sample space. Out of that 2 days sample space is this one. Number of days in sample space equal to how much? 7. Now what is our question? Now you can think. I am defining one event here. A. What is our event? 53 Sunday occurring in a leap year, correct? 53 Sundays occurrence, right? 52 Sunday occurring. Okay, so what will be the outcome? What are the outcome we need to take if you want 53 Sunday? 52 by default is there. If you want 52, what are the outcome will take? If it is coming Sunday, Monday, one more Sunday will come, so it become 53 Sundays. 52 default is there. If we are coming Sunday, Monday combination, one more Sunday extra will get it, correct? So 53 it will come. Otherwise, see, Saturday, Sunday, this coming also we will get one Sunday extra, correct? So 53 Sunday occurring means what are the possibility? Either it should be Sunday, Monday combination, or it should be Saturday, Sunday combination. So it will be 53 if it is coming like that. So how many elements here? Number of elements of the event A means 2, correct? Number of events, number of elements in the event A is 2. So we can now define the probability, correct? So probability of in a leap year 53 Sundays, 53 Sundays in a leap year, correct? In a leap year, what is the probability? Probability of A, correct? Probability of A means number of elements of A divided by number of elements of A divided by number of elements of S. What is number of elements of A? 2. What is number of elements S? 7. So 2 by 7 is the probability of 53 Sundays in a leap year. Hope you understood. So 52 Sunday by default is there. 52 Sunday, 52 Monday, 52 Tuesday. This is default. Then extra 2 days, that depends on our 53 Sunday, correct? So one more Sunday, if you are getting 53 Sunday will come. So one more Sunday coming, what are the possibility? Either Sunday, Monday, or Sunday, Saturday, correct? So 2 possibility to that event divided by total number of possibility is 7. So what is the probability? 2 divided by 7 is the probability. So that is the idea here. Okay, you can practice that question again so that you will understand the idea. Now same model, one more question I can do here. For example, see here. Same idea, small difference only. How likely is that leap year will have 53 Sundays and 52 Mondays? Monday should be 52, but Sunday 53. What is the probability? How likely means what is the probability? Okay, how likely means what is the probability that a leap year will include 53 Sundays and 52 Mondays. What is the probability? We need to calculate that one. So same idea whatever we did the before question. First I can write number of days in a leap year, correct? Number of days in a leap year equal to 366. So number of weeks in a leap year equal to 366 divided by 7. So we will get 52 weeks. We will get 52 weeks plus 2 days extra, correct? 52 week, after that 2 days extra will be there. So 52 week means we have 52 Sundays and 52 Monday should be there. 52 Tuesday, 52 Thursday, all the days 52 times it will come, correct? Now these 2 days depends on our answer, correct? We need what? We need 53 Sunday but 52 Monday. Monday should not increase, but Sunday, one more Sunday extra we need to get it. What is the probability? That is the question, correct? So first we are writing that 2 days, what are the possibility, okay? These 2 days. So total outcomes with these 2 days, correct, equal to, either it is, as I told you, that 2 day will be Sunday Monday, or Monday Tuesday, or Tuesday Wednesday, or Wednesday Thursday, okay, Thursday Friday, or Friday Saturday, or Saturday Sunday. So number of elements of S means equal to 7, sample space equal to 7. Now what is our event here? A means, what is the event? 53 Sundays and 52 Mondays. 53 Sundays and 52 Mondays. Okay, so what is the possibility we will take from that? Okay, what are the outcome favorable to this event? 53 Sunday. Sunday, one more Sunday we need to increase, but Monday should not increase. Okay, Monday by default 52 is there. So what are the outcome we are taking from here? You can think about that one. What outcome we need to take that one, correct? Sunday, one more increase means Monday should not increase. So this one we can take, Saturday Sunday. So no problem, Saturday Sunday. So one Sunday will increase, correct? Monday we cannot increase. This one we cannot take. Why? If you are taking Sunday, Monday, one more it will increase. It will go 53 Monday. So it is not possible. Okay, we need 52 Monday. So only Sunday, Saturday and Sunday only we can take. Other one, there is no Sunday other than. Okay, so only one outcome. Correct? Yeah. Sunday and Saturday, S and S. Okay. S and M we cannot take because Monday will increase. M and T we cannot take, Monday will increase. Tuesday, Wednesday no benefit because there is no Sunday, Monday there. So Wednesday, Thursday no need, Thursday, Friday no needed, Friday, Saturday also no needed. Only Sunday possibility we are taking because Sunday only we need to increase, but Monday should not increase. So SS. So how many elements in A? Number of elements of A equal to only 1, correct? Now you can calculate the probability, correct? So probability of A, probability of getting 53 Sundays and 52 Mondays equals number of elements of A divided by number of elements of S. What is the number of elements of A? 1 divided by how many number in S? 7. So what is the answer? 1 over 7. I hope you understood this question. Okay. Now one more question lastly we will do. If B subset of A, B subset of A, this is a different question. If B subset of A, so B subset of A means A is the bigger set, correct? B subset of A, so this is the bigger part. A is the bigger set, B small set. Okay, so here I can show A, B subset of A. A is the bigger set and here B. B is this inside small set. It is a subset, correct? And A and B are two events such that probability of A given. What is probability of A? Equals 3 times probability of B. Probability of A equals 3 times probability of B. And A union B means equal to S. S means sample space. What is probability of B? That is the question. Probability of B equal to how much? So for that use this rule. You remember A union B rule, correct? So probability of A union B equals probability of A plus probability of B minus probability of A intersection B, correct? Using this rule, probability of A union B equal A plus B plus B minus probability of A intersection B. Now, what is probability of A union B? Probability of A union B. What is A union B? Here it is mentioned. S, sample space. So, S, probability of S equals probability of A value given here. What is that probability of A? 3 times probability of B plus probability of B, we don't know, we need to calculate, minus probability of A intersection B. You can see, for example, see in this picture, B is a subset of A. So what will be the A intersection B? A and B common portion. What is A and B common portion? This is the common portion. Same as B, correct? That means here A intersection B means same as B. A and B common portion is B only, correct? Because B is the small set, it is inside A. So common portion is B, same as B. So what we can say, instead of this A intersection B, we can write it as B itself. So probability of B. Hope you understood that one, because intersection is same as B. Now here what term we can cancel? Plus probability of B minus probability of B cancelled. So what is balance? Probability of S equals 3 times probability of B, correct? Now what is probability of a sample space we studied? Probability of S means 1, correct? So probability of S is 1 equal 3 times probability of B. From this you can divide both side by number 3, here divide by 3, here divide by 3, you will get what is the probability of B. So what answer getting? Probability of B equals 1 over 3. That is the answer here. So answer is probability of B equals 1 over 3. So I hope you understood the ideas in this exercise 5.1.2. It is little lengthy exercise, more questions are there, and it is logical questions. Okay, you can practice more times. So that's it, the topic here. I hope you understood the ideas. Thank you for watching. Please subscribe my channel for getting more recorded classes. Thank you very much.